Welcome to Clinical Chemistry 1, Chapter 2, Safety Review. I forgot to mention in my last segment that this is actually me working in the clinical chemistry department at Bellin Hospital in Green Bay. As you can see, there's a lot of computer screens and things behind me. To my left that you can't see is some very large clinical chemistry analyzers that we were able to control and see the results from on those screens that you see to my right. So it was a really fun job that I had before I came here, so I like to show a picture of how much fun I had doing it. So anyways, let's move on to some safety. As you can see, I do have my lab coat on. I don't have any eye protection wear on at this point because I wasn't dealing with any samples. I was working with the computers. All right, first thing is OSHA. It was enacted by Congress in 1970 to ensure all employees have a safe work environment. It conducts inspections to make sure that standards are being followed in these areas: bloodborne pathogens, hazard communication, and personal protective equipment standards. Places of employment need to make sure they have these things in place for their employees. Different agencies or external reviews that also look at safety: JACO, that is the one that looks at the accreditation of the hospital as a whole. Not just the laboratory, but nursing and surgery and ICU and all those emergency department, all the other places in the hospital. CAP, the College of American Pathologists, is a higher level of certification that a laboratory can obtain to prove that they're doing the highest standards of safety and laboratory resulting. NACLS, that is the National Accrediting Agency for Clinical Laboratory Science. They accredit Rasmussen, and one of the things we do when they come to campus is they check to make sure we've got fire blankets and eye washes in place. We have MSDS manuals and things like that. So safety is part of the requirements for accreditation for all of these agencies, not just OSHA. It is the employer's responsibility to make sure that training is available, safety information is available, the proper personal protective equipment is available, that they maintain equipment and make sure it's in a safe type of state. You don't want frayed wires sticking out or anything like that. Supervision and guidance must be available for the employee. So everything has to be provided to you as an employee. But it's also your responsibility to do what they tell you. Okay? You need to comply with the safety methods and keep a positive attitude. Don't be mad because you have to wear gloves, face wear, and a lab coat. Okay? Be glad that they provide you with those things to prevent. I mean, how many times I've spilled urine on my gown and my shoes? When they tell you to wear leather upper shoes or shoes that are solid on the top, do it. Because I wore my running shoes one day because I forgot my leather upper shoes, like the nursing shoes, those nursing clogs were something that I always like to wear because the top is completely covered. When you spill a urine on the counter and that falls on or drips down your foot and goes through that mesh on your tennis shoes and in between your toes, it is not a good feeling. It's disgusting. So make sure that you really do follow these types of things. When they tell you to pull your hair back, pull your hair back. You don't want your hair to be falling into things and it may contaminate a sample or you could contaminate your hair. So notify them when you see unsafe conditions as well. If you see something broken or frayed wires, that's when you want to contact management to let them know. Use all the safe work practices provided, including wearing all the PPE provided. Signage and labeling. Be familiar with this. You learned about this in intro, so it's not new. But the NFPA standard hazards identification system uses a diamond-shaped code. This is different for each manufacturer of a chemical. If you look at some of the chemicals you have in your laboratory, not all of them have this symbol on it. Some just list fire, health, reactivity, and with a number after it. Know that blue is a health hazard or toxic, red is flammable, yellow is reactive or oxidizing. You have a quiz coming up. This is going to be on there. 50% of people get yellow wrong. Yellow is reactive. They always forget that one, so just make sure you know that. White is other. It might be don't add water or something like that. Each area is then graded from 0 to 4 depending on the severity of each hazard. So the higher the number, the more severe it is. Make sure all chemicals are labeled. It needs to have a chemical identity, the concentration, the hazard warning on it, special handling, storage conditions, the date that you prepared it or opened it, when it expires, and the fact that you made it. You see some bottles here that have some labels on them. So safety equipment, all labs are required to have safety showers, eye wash stations, and fire extinguishers. In the Rasmussen laboratories, you're not going to see a lot of showers because we don't really have a lot of things that are going to either A, start you on fire or in a high enough quantity to need a shower. But we do have eye wash stations. If you don't, let your lab adjunct know because we should have them. Fire extinguishers are usually located right outside in the hallway next to the laboratories, and it needs to be tested and documented. Fume hoods are not something that you see in the Rasmussen laboratories because we don't really have things that need them. But as you head out to your clinical externship sites, you will use quite a few fume hoods, especially microbiology. They need to be inspected for blockages, make sure that the air flow is working correctly. And there's usually a bunch of levels of biosafety depending on what's being performed. So depending on where you're working, they'll have the proper biosafety hood for you. Chemicals should be stored in a cabinet. They should be stored, I keep mine down low because on the Green Bay campus we have our acid cabinet down on the floor because I don't want someone reaching up above them and think somebody may have not put a cap on tight enough and splashed acid in their face. So I find mine to be safer at waist level or lower. Here's an example of some employees wearing their proper PPE. Biological safety, no standard precautions. Treat everything as though it's potentially infectious. Personal protective equipment should be worn. Wash your hands. Keep specimens capped during centrifugation, which could disperse aerosols. They need to have a bloodborne pathogen exposure plan. The purpose is to minimize employee exposure. There has to be a written exposure control plan, has to be discussed with you when you start the job, and you'll be given a training of all techniques that are in the control plan. We also need to be aware of airborne pathogens. I have an example of a room that a tuberculosis patient might be in on the bottom right-hand side. If you do have to draw blood from or have cases of tuberculosis that you're dealing with, you need to wear a special type of respirator, an N95 type of respirator, that would prevent you from inhaling any type of TB spores that might be in the air. And you have to go through a special training for that where they put this big helmet over your head and they spray this bitter green apple spray, and if you can taste it, it means it's not working. So you have to go through training before you could ever draw a patient like that. And also you go through mandatory annual screens for TB. You'll actually have a TB skin test before you go out for your clinicals. Shipping is important, as you can imagine. If you do need to send things out to a large Mayo or Marshfield clinic, something like that we would find in our area, you want to make sure that it's DOT acceptable, it follows the International Air Transport Association, and it's properly labeled with biohazard types of stickers. All materials need to be labeled as such. Diagnostic specimens label for those tested as routine or screening for initial diagnosis. So see these little, usually this orange one will be seen on the outside. And it has to be within a bag inside the box in case something were to leak. And there's absorbent material in there as well. The chemical safety hazard communication, OSHA says that you have to communicate with people exactly what they're using. It's also known as the right to know law. It's developed for employees who may be exposed to hazardous chemicals. You can't have them work with chemicals and not tell them that they're doing so. Labs are also required to have a written hazard communication plan. You have to have the MSDS for each chemical available, which you should have those in your labs. Educate and train all employees on how to read the chemical labels, MSDS, and health hazards, and maintain hazard warning labels on those containers. We have different types of chemicals that you may see. Be familiar with these. They can be flammable or combustible, which means they can start on fire. Corrosive means they can cause injury to the skin or eyes. And it can also affect your GI tract or tissue if inhaled or ingested. Reactive means it could explode. Carcinogenic means it can cause cancer. And a teratogen means that it can affect a developing fetus or embryo in a pregnant mother. We have some classifications of fires. Class A is usually paper, wood, plastic, clothing. Think of your typical house fire. Class B is a flammable liquid or a gas, so if something were to start on fire at like the gas station, if a pump were to start on fire. Class C is an electrical fire, and Class D are combustible or reactive metals. Probably the least common would be Class D. And the last thing with safety is accident documentation. Even if you follow all safety rules that have been given to you within the laboratory, accidents and injuries must be reported immediately to your supervisor. There's usually going to be a non-penalty procedure that is followed. If it's a needle stick, you would need to follow the needle stick procedure and get your blood drawn. And well, usually you get your blood drawn, and the person whose needle it came from, if you know, would get their blood drawn for HIV, hepatitis, and things like that. The employers are required through OSHA to maintain records of injuries and illnesses that may have happened at work. And documentation includes what the report of the injury was, the investigation report, and an annual summary. Okay, this concludes our safety chapter. Please move on to watch chapter 3, which will be talking about statistics and method validation.